Welcome everyone to Building SaaS on AWS. My name is Christopher Logan, your host today. So this is the show where we talk about the innovations, best practices, and all of the hows of building SaaS on AWS as we can fit on. Today is our penultimate show of the season, so our second last for this season, but we will be back in February for a whole other season of Building SaaS. So it's my pleasure today to have two phenomenal solutions architects from our ISV team here in Australia. So we have Sri Nadendla, our principal solutions architect. Welcome, Sri. And we have and we have Miranda Lee, solutions architect also for ISV. Miranda, welcome.
Hello, Chris. Hello, everyone.
So today we are talking about a very, very specific topic, and that is AWS native access control for APIs. So I'm not going to go and intro that. I'm going to leave that to Miranda. So what would be great if Miranda, if you can intro us on what that is and why it's important for us to talk about it.
Well, first of all, there is a saying: without any authentication or authorization, there is no data security to speak of in modern applications. In almost every single data breach, access controls are among the first few policies that's ever been investigated. In modern applications, how we define the resources that needs to be protected. They can be your data, they can be the information assets, they can be the business processes. And they are increasingly modeled and implemented as the APIs, especially over the last decade. And this is an established norm now. So right now, whenever you want to write an application, you put an API in front of your resources. So it becomes imperative to protect such assets from undesired access by enabling those right level of access to specific resources for the specific users. This can generally be achieved through the role-based, or we say attribute-based access controls, and AWS has a whole set of tools to enable you to do so.
Awesome. Thank you, Miranda. Sri, how does this help us with SaaS and for tenants in SaaS?
Yeah, that's a really good question, right? So if you look around us, especially over the last decade, the number of SaaS applications of various kinds have just exploded. And there is enough evidence to suggest that this will only go on for some more time. So in fact, today, it's very hard to imagine not having a SaaS application these days, whether it be within a particular industry, a vertical-based solution, or something that is horizontal that is applicable to various businesses. So essentially, all these SaaS applications today, they have varied functionalities and they serve businesses of different shapes and sizes. So at some stage, SaaS tenants, which is the SaaS customers or SaaS clients or SaaS consumers, I'm going to use those words interchangeably today. So these SaaS tenants are going to ask the SaaS providers to perhaps have the ability to carve permissions to functionality, to use Miranda's words, to be able to provide the right access to the right people, to be able to do the right stuff, right? Using that functionality that the SaaS provider offers.
Right.
So perhaps one of the best ways to showcase this is using a visual aid. So let me use a simple diagram to explain that. Yeah, so in this particular one, you'll notice on the left-hand side, you have a SaaS customer, client / tenant. And on the right-hand side, look at in context or within context of the SaaS application, which is referenced as SaaS product. you have some out-of-the-box roles, right? So as a SaaS provider, you pretty much understand what kind of solution or what kind of functionality that you're offering to your prospective customers and existing customers. So you can take a judgment call on how perhaps your customers would want to carve some permissions. So in this case, we're only talking about out-of-the-box roles, but for today's discussion, in the interest of time, we will not get into how you can even enable as a SaaS provider to create custom roles by your clients. So let's keep that or park that for end the conversation. So in this instance, as you can see, there are various tenant organizations that you onboard onto your SaaS product, and each tenant organization comes with stock standard pre-carved out-of-the-box roles. And there is a subtle indication that we want to make, which is quite emphatic, which perhaps Miranda will touch on later on, is we perceive that all functionality, all data assets, whatever you call that a SaaS application provides, can be modeled and be implemented and will manifest as APIs. And therefore, if you're able to create this mapping between roles and the APIs, that eventually means that different users on your customer side can have the right level of access to the right functionality without needing to have everybody access everything, which is a recipe for a bit of a data security problem.
So Sri, look, I agree with you. The SaaS is it's the whole reason why we have this show, and we have a whole bunch of other resources for companies who are running SaaS. There are some predictions that the SaaS market by the end of next year is going to be something like $60 billion worldwide. We are seeing more and more SaaS applications used in companies, something like 30% year on year. It's only getting bigger. So it's a topic that holds a significant weight in our industry. It will start to hold a significant weight in a lot of industries as it grows. So let's start to do a little bit under the covers here. I'd love to have a look at some architecture.
Yes, indeed. So it's always the case that a visual representation of some nature, especially architecture, will put in context the core moving parts. And the whole idea is we want to be able to share what are these moving parts. But before we dive into the technical architecture, I would like to quickly touch on a reference model for authorization. Only because it helps to establish the conceptual capabilities required in creating an authorization system in general, right? And perhaps these abstractions will also help our audience, especially those which have existing tech stack outside of AWS native services. So there is a way for such customers who have such investments already or pre-existing tech stacks to perhaps evaluate which part of their existing stack can be evolved to implement authorization conveniently. So let me start off with a reference model. At its most essential level, and this is the reference model and the specific constructs of policy enforcement point, policy decision point, policy store / policy information point. So these constructs have existed for as long as probably when we started to have multi-user computing. And they still relate to authorization. And anybody in any circumstances, regardless of which business type, if you have multiple users where you want to create an authorization system, you will have to start from the first principles, and this is where you will end up being. Now, the reason why we touch on this is so that you can look at what role a particular moving part within an architecture is performing, and how does it map back to one of these three things in an authorization implementation. So that is an absolute key. So one of the reasons why we're projecting these concepts in this diagram is to contextualize what happens in an API invocation situation. So you have a client, you have users on the other side of the client, they try to invoke an API. Your authorization system, what it does is it reaches an API gateway, which is perhaps where your API endpoints are first hosted. And this is one of the very popular patterns where everything is centralized, meaning you have an enforcement that will talk to a centralized decision point, which is able to reap the mapping between should I or shouldn't I allow this particular user to have access to this particular API or resource, right? So this is one of those very predominant patterns that we notice. And you might be wondering, okay, if API Gateway is performing the enforcement function, who is performing the decision point and the policy information store, policy store function? So, which is where I think it helps to then dive into the AWS technical architecture. So this probably helps with what are all the moving parts on AWS that we will be talking through for the, let's say, rest of 30 minutes, constitute of. And we're talking about cognitive identity pool, cognitive user pool, API gateway, and IAM. And because we specifically touched on the reference model and the core constructs, which is PEP, PDP, and PIP, which are the short forms for the things that you've seen before, the way the responsibility is separated in the AWS native implementation for authorization is API gateway obviously plays the role of enforcement point for any API that is being invoked against API gateway with API implementation behind the scenes. And you can do that on any compute, whether it's Lambda or containers or even EC2. IAM, the combination of IAM and cognitive user pool play the role of policy information point. So this is where you can keep the mapping between the roles and the corresponding APIs, and perhaps even users and the role mapping. And I'll go so far as saying that one of the best conveniences that you would achieve in AWS native features is the integration between API Gateway and IAM. So all you have to do is choose IAM as the authorization mechanism in API Gateway, and IAM, AWS IAM will perform the decision point function or that role. So we will come back to this at some stage during the conversation, but quickly stepping through how these things come together in context of, let's say, in a request. So what I'm trying to showcase here is in context of a request. When a user is accessing a certain client, this client could be a web application or a mobile application, right? So it's trying to invoke an API. Here, we are trying to authenticate against cognitive user pool, and it issues an identity token, right? And along with it, an access token. So this ID token is then used against cognitive identity pool to get back AWS temporary credentials. Now you're wondering, how does that happen? Like, how does cognitive identity pool know what permissions would or should it associate with the temporary access credentials? And this is, again, going back to the native integrations between AWS services. The ID token has role information that we had configured in user pool when the user authenticated. Using that role information from the ID token, identity pool is being able to issue secure access key and secret key, which is temporary access credentials, with the permissions or the permission scope of that particular role, right? So stay with me for a very brief moment, and this will all be a lot more clearer as Miranda will step through what it will look like to actually configure it this way and see it in action. So the last step is basically use the temporary access credentials and sign the API request going through to API Gateway, where it is being configured with IAM as an authorization mechanism. So long story short, it is these four services and the native integration between these services that makes it really convenient for anybody looking to implement access management and access control for custom APIs that have been defined by the developers of your corresponding organizations and hosted on API Gateway.
Okay, awesome. There's a lot of stuff there. So let's step into a demo so this starts to become tangible and real. Miranda, that would be awesome to see.
Yeah, 100%. First, in order to demonstrate what I've built over here, yeah, thank you so much. There is a simple diagram. Actually, what I've done is very simple. Color picker application. And inside of this color picker application, I only have 4 buttons. which is blue, green, red, and yellow. And each of those buttons are wired up to APIs on the back end, and it has its corresponding names. I also created 2 users inside of the Amazon Cognito user pool. One of them belongs to a group called Blue Group, and he or she only have access to one single API, which is Blue. So whenever I click that blue button, this user should have access to it. And another user has access to all the 4 APIs. I call it RGBY group. So red, green, blue, and yellow group. So this user is, you can say it's an admin, so he or she would have access to all the blue, green, red, and yellow. Let's just take a look at what's inside of this application. Okay, don't mind the design. So first, let me try to log in as a Blue only user. I call it Blue only. So let me just input the password. Sign in. And I like to draw your attention a little bit on the right-hand side over here. As you can see, there are lots of calls happening between the Cognito and my application. So those are all done by Amplify libraries. And like previously, what Shui has described, this is a process of changing my access to the AWS temporary credentials. I won't go into the details of how does this happen, but let's look at the access over here. So technically, this user should have access to Blue. Okay, let's just click this button. As you can see, I have 200 as return. For green, yellow, and red, all those 3 buttons, I don't have access. They show as red over here for all 3, access denied. Okay, let me sign out and sign in as my RGBY user. Okay, another set of token exchange happening between my front end and I am Cognito. And when I log in as this user, I have access to blue, green, yellow, red. All the 4 APIs have access to it. Okay. Yeah, let me just assign it. And what actually happens is inside of the Cognito, I put those 2 users into 2 groups. And this is easily done.
Okay. So it's probably not worth looking at the code of that app, which is not going to help anyone. But I'd love to see how this was configured. Like what were the configurations? What were the integrations that went into pulling this together? If you can walk through that, I think that'd be super helpful.
Yeah, 100%. Yeah, the code itself is super simple. If you leverage Amplify library, it's probably 20 lines of code over there to implement this whole thing.
Nice.
So yeah, it's pretty convenient. So first, I like to draw your attention on the setup in those color APIs. Like I said, I have blue, green, red, and yellow. Let's just look at one of them, not all of them. Look at the blue. What I put is AWS IAM as its auth, so authentication and authorization method. And also another thing we need to note is this ARN that's attached to this API gateway. We will be using this in our IAM later on. So, okay. Now I've told the API gateway, please look at the AWS IAM credentials whenever this call is coming in. And this IAM is actually tied back to my Cognito user pool. So inside of my user pool over here, basically I only have 2 users just for the demonstration purpose. One of them, this one is RGBY, so this one should have all accesses all the 4 API accesses. So I give this person the tenant admin group. Let's take a look at what's inside of this admin group. So basically, as you can see, this is nothing fancy, but notice I have a IAM role that's attached to this group. Let's take a look at what's inside of this IAM role first. Okay, so inside of this IAM role, as you can see, I grant the permission of execute API, invoke this API, all 4 accesses, blue, yellow, green, and red. And on the other hand, another user, which is called, let me go back to this one, which is called blue only. So this user, the group membership is tenant user group. So what does this mean? Okay, again, it's another IAM role attached to it. Let's look at what is specific, special about this role inside of my IAM configuration. So in this role, as you can notice, I only have one API invocation granted for this user. That's why this user is literally locked out from the other API calls like red, yellow, and green. So this is how it works. And another thing I think we need to set up when we enable this integration is inside of the Cognito, we need to have a identity pool setup. And inside of this identity pool, we'll use the Cognito as the identity provider so that it can come into this identity pool and exchange the username password and the access token into the AWS temporary credentials. Don't worry, this might sound a little bit too much to set up, but this is more like one-time setup. And if you use Amplify library, this or implementation is pretty much hidden away from you. Yeah.
And Miranda, I think one of the things that you're trying to highlight here is that drop down which says choose role from token. So that is one of the convenience of native integration between these services, I suppose. Is that right?
Yes, exactly. So if no roles are specified in the token, then the role resolution will be invoked. So in here, we just deny any role resolution because we will tie it back to IAM as the authentication authorization method. Yeah.
And basically, this is the role that you have defined in Cognito user pool, which is mapped to a group. Like there's a user group, and then there is an AIM role. And this is the role that gets picked up in the ID token.
Yes, exactly. So I basically exchange everything into this IAM role over here. And this role do have the access to different APIs, depends on my configuration. So this is how you put the API access control behind your API gateway over there. Yeah.
And so when the Cognito identity pool exchanges for a temporary access credential, it is based on the role information, based on the dropdown that has been chosen, the group role association user pool. The temporary access credentials would start to have permissions, which is equivalent to the policy that you're showing here.
Yes, exactly. So when the user has reached this identity pool, what happens is if there's a role that's already associated, then it just inherits that role. But if there's no, what we chose over here means, okay, we just don't do any role resolution. So if the user does not have a role that's associated when they come into this identity pool, then nothing will happen. Yeah, they will just be denied with access.
So there is there's a question that the audience, one of our users, Lavis, asked. I'll put it on the screen. Cognito user is mapped to a group, which is mapped to an IAM role. So either Miranda or Sri, do you want to talk through that?
Yes. I think Lewis, your observation is 100% correct. So basically, I give this blue-only user the group membership of tenant user group. And this group is attached to this IAM role. And this IAM role has the right to call a particular API. So this is how the mapping goes. User to group, group to IAM, and IAM again tied back to the API.
Okay, awesome. Another question, which is actually I think is super worth pausing to talk through here. The front-end request to the API include the ID token or the access token?
Okay, this is a very good question. So okay, my login is expired. Let me log in again and show you how this everything happens.
While Miranda is doing that, probably I'll quickly add some comments there. So what happens is when an API is actually invoked, this is again the native integration that is coming into play. And Miranda probably will touch on how that happens behind the scenes. Perhaps is the API request is SIG-v4 signed using the temporary access credentials gotten from the identity pool. So the client application has now swapped the ID token for temporary access credentials, which are used to sign the API request heading towards API gateway. And that is then captured in the authorization header of the API request. And it is not your typical JOT token that goes to the API gateway. It is a SIG-v4 signed some sort of a token that is done using the access credentials that API gateway and IAM can interpret.
Okay, that's a really nice explanation over here. So as you can see, in one of those cognito calls, one of them would return you the secret key and session token over here and access key ID over here. So what I have inside of my coding, sorry, Christopher, I'm showing a little bit coding.
No, good.
So basically, yeah, what happens is this amplify library over here inside of this API, it will automatically attach the secret key and access token and form a SIG-v4 sort of credential and make it useful when I'm clicking those buttons. So if I click this blue button, if I inspect the headers over here, as you can see this in this authorization, there's a SIG-v4 signature over here. And another thing is attaching is this Amazon security token. So this is all automatically applied if using an amplifier as a library or framework.
All right, wonderful. Thank you. Thanks to the audience too for questions. Keep them coming. We will answer whatever you've got with respect to building SaaS. Sri, let's switch gears a little bit. How does this differ when we are talking about SaaS tenancy model?
Yeah, so that's again, I mean, the whole point here is we wanted to show all the moving parts to get the AWS native implementation going. And more importantly, we wanted to highlight what are some of the native configuration and integration aspects that come to your aid when you're trying to get all of this going. And before I touch on, what will it look like for SaaS tenancy models, one of the things that struck me as Miranda and I, as we discovered more of these things to implement similar systems, again, we were working backwards from some of the challenges the customers were trying to find a solution for. And that was the inspiration behind why we both spent the time to look at this. More often than not, customers have implemented these mappings, especially the policy information point, which is the mapping between the role or the group to functionality, which is represented as APIs, is, for good or for worse, we noticed quite a few customers configure them in relational databases or perhaps a data store of their choice, right? And in this particular implementation, you notice that all of that heavy lifting is actually done for you and kept within the user pool and IAM. So, and one another aspect, which I think is pretty good, having done these things at a bank before I joined AWS, is AWS recognizes each and every API endpoint with an ARN, regardless of how deep your path is. Now that is super useful because the moment it is an ARN, and it can be so fine-grained as the deep path that you have used for those APIs, IAM recognizes it as an independent entity, which means you can go really fine-grained, creating the permission scopes within the policy document within IAM, and then simply attach them to the roles, which you can map to your users using the groups. So I think those two aspects are I think, quite unique and quite convenient. So I would definitely encourage those who are looking to implement these things to take into consideration some of the native conveniences that AWS offers. So coming back to your question, which is, now, what does this all mean in SaaS context? Especially, we have tenancy models, right? And I like to think of them as tenancy models on a certain spectrum. On one end of the spectrum, you have silo tenancy model, and the other end you have pooled tenancy model, and in between is the bridged model, where for some of your tenants you go siloed, and some of your tenants you put them on shared resources in pooled. So let me very quickly, and I put in front of you a couple of stats which will play a role in how you would implementation be influenced. So the primary factors to consider is in a siloed way, where by definition you can dedicate resources on a per tenant basis. So in this instance, if you cast your if you can visualize the four key moving parts, which are the AWS native services, the user pool, the identity pool, API gateway, and IAM. And if you consider them as the key resources that you would need to use to implement this, if you have to dedicate them, essentially, yes, you can go ahead and use the implementation that Miranda pretty much showed in a siloed model without any changes whatsoever. It's just that the only thing that you have to do is recognize which tenant is mapped to which particular user pool, right? Or identity pool. Now, that is where we live in a constrained world, right? I mean, it's not an unconstrained world. This is where, while from a requirement basis, siloed is dedicating resources, from a constraint standpoint, we have to be aware of, if not cautious, be aware of some of the limits that play into this, right? So you can have 10,000 user pools per AWS account per region. And similarly, you can have 10,000 groups in a user pool, right? Looks like there's a question. Do I take it? I go through this?
If you can, sure.
Okay. So let me read out the question. Is that okay?
I'll put it up.
Yeah, perfect. So if you have hundreds of APIs, you would have to split them across multiple policies and attach these policies to the role up to a limit of 20. What if you have more? So that's a very good question, right? This is where the constraints of the real world implementations come into play. And this is where we'll have to consider. And this is actually a good question, because the response to it actually cues nicely into the idea of going into pool model, where if you want to, so long story short here, some constraints will push us towards considering sharding our resources against the tenants or the growth of the tenants. Invariably, regardless of which infrastructure you use or which technology you use, all of them will have certain limits, and those limits are there in some cases to protect you from overusing them, or because everything has a cost association. In other cases, it's just the technology limits, and it comes down to the principles of physics, right? So in such constrained situations where you're trying to unlock or go beyond a roadblock or a constraint, you'll have to think about sharding your resources. Therefore, you're able to improve the capacity at your disposal that you can associate your tenants to. So, for example, if you come up against a particular limit, think about if you were to go with another instance of it to use and split your tenants across.
Cool.
And so that leads nicely into the aspect of in a pool model. So where you could go with shared resources or shared at the most basic form, if you could think of as if you have your microservices that are servicing multiple tenants, they're all pretty much hosted on a shared compute. But let me bring that into the context of authorization here with those particular 4 moving parts. The user pool is where, so there are 3 things that you have to consider, right? One is the groups in the user pool, the group mapping to the roles, and the roles having the policies associated with them. And then the idea of identity pool being able to get temporary access credentials for that role scope. So again, based on the scale of your tenants. So if you are a B2B, which is largely servicing, really large customers, where the number of customers, meaning the number of tenants may be fewer, but the number of users for those tenants will be greater, right? Then you can definitely use the pool model where you're not exhausting the limits on user pools or user pool groups. You're able to service different users. So there you can simply dedicate user pool to a tenant given the sheer number of users and perhaps the potential groups that you have to carve. But if you have greater number of tenants, but each tenant will have fewer users, and if you're providing a functionality in a way that helps you be consistent regardless of which tenant and the users that they have, then again, depending on the scale of those tenants, start with one user group, one user pool, and see if you bump up against the constraints based on your growth projections, in which case consider sharding. So again, I'll go with that analogy of the ends of spectrum. On one end of spectrum is you have one user pool and you pretty much concentrated all your tenants in one user pool. On the other end of the spectrum is you've dedicated it. And in between of that spectrum is the idea of sharding, whether it's be based on scale requirements or whether it's be based on constraint on resources or limits. So that would be the key.
Awesome. Thanks, Sri. So I'm going to shift also a little bit here. This brings up another question, as in when we are talking about access control, where do you put it? At what level do you call the access? Is it right up the front? Is it down towards the APIs and the backend services? It's a hard question, Miranda. That one's yours.
Okay, yeah, that's a really good question. I think this would partially contribute to the question from the audience, where when you have a few thousands of APIs, and how do you deal with access control over here? So first of all, let me just bring up a chart for what would be the modern application normally look like. So okay, this is your SaaS application over here. You have your front end with a whole bunch of features, 100 different features. And then you have quite a few APIs. Those APIs are backend for front end. They just listen to those buttons. And then after those APIs, you would then have another set of APIs sitting over there that's probably providing some database access or static assets or some of the business logics behind the scene. So The question over here is, all those points actually can become the decision-making point. But the question is, do you need all of them to be able to responsible for the decision-making? Of course, the benefits of you enabling the access control in every single decision point is you have pretty solid application over there. Based on the user's attributes, based on the information you carried all the way from the cognitor, you can have those if else. But again, the problem of this is it will become a largely decentralized responsibility across all different APIs, and different APIs needs to know, okay, who am I, which feature I belong to, which kind of audience I'm serving to. That can become a problem as well. And to be honest, sometimes if your data classification, your feature classification is okay with it, maybe on the last layer, you don't need that strict access control over here. Or even for some of the backend for frontend, as long as the user is authenticated, authorized, then you're good to go. In order to ease the burden of mapping those complex feature, I think we can actually do a little bit traditional feature toggle-driven development inside of this. It might help. I think another way to build this would be have a centralized decision-making point. But again, this centralized decision-making service would become a bottleneck if, say, every single API is trying to call it. So again, I think there is no right or wrong answer to this question, but it's more like, okay, how much responsibility versus how much the operational manageability inside of your implementation over here. Yeah. Sometimes it just makes sense to leverage the feature management tooling. Sometimes you can just DIY the whole system. Yeah.
So, like we all know that in a SaaS multi-tenancy world, the other issue is data isolation. Does this help in that scenario as well?
Yes, I would say 100%. You can leverage the access control to protect your data as well. So because access control is just all about preventing the inadequate access from happening, right? Tenant A should not be able to see what's inside of tenant B, and this problem naturally falling into the access control category. Let's just say you have this 3-tier web application. You have front end, you have back end, and you have another data layer sitting over there. So normally, how would you feed the data all the way from your database back to your front end? The most straightforward way would be just put an API in front of your database and control the access from API level. And we can just restrict the database access, lock it down in the API level, and we manage the user access on the API level itself. This can based on role and attributes like we demonstrated over there. Another scenario would be a data-centric access control. In here, some of the data technology nowadays will have its own access policy in place. For example, S3, you can actually implement access control list on top of S3 bucket, and even in every single one of the objects inside of S3, you can let S3's policy to allow or deny a upload or read action. Or you can even implement both layers for highly sensitive data that should be protected with extra care. But again, this methodology will require extra layer of access control implementation. Some of the data technology just does not support it, especially some traditional databases out there.
Awesome. Thank you, Miranda. We have an audience question, which from LV78. Let me put this one up. In the pool model, how do you suggest to structure the groups if you have multiple roles within each tenant? This is something that we did talk about before the show. So happy for either of you to give your opinion on that one.
I'll take the first shot and then perhaps ask Miranda if she would have additional comments. So right now, the way you've seen the implementation, it's a clear one-to-one mapping between a user pool group and the IAM role. Although technically you can have multiple roles, what cognitive user pool does is it asks you to choose a precedence, meaning although you have multiple role mappings, you have to choose a precedence and that will be set. So I'm trying to understand what could be a practical problem that this particular question have been inspired from. So I'll ask you to cast your imagination back to that particular slide where I tried to showcase as a SaaS provider, you can give pre-canned roles, and these roles have pre-canned permission scopes against these APIs.
Do you want me to put that back up on the screen? Sorry, do you have that?
Let's try that. So I think it helps, I suppose. So again, the person who asked the question, tenant admin, tenant user, structure the groups if you have multiple roles. I think the first things first is for the implementation to work, it is one tenant user group, user pool group to IAM role mapping. So if you have a tenant admin, in this case, I'm calling it SaaS admin, or tenant user, in this case, I'm just calling them the normal user. These are pre-canned roles. You can create them and you can have corresponding groups or group names created in user pool. And by the way, when we refer to that, there is an inherent assumption I'm making here that you have one tenant in a user pool. If you have to service multiple tenants in a user pool, then think about this. You, as a SaaS provider, are in control of which pre-canned roles and permission scopes you want to create. So if, let's say, Miranda and myself are two different consumers, but Christopher, you're providing the same service invariably, you can pretty much give us the same or associate us to the same roles that we need to get our job done, right? So as a SaaS provider, you are in the driver's seat. So you can create the pre-canned roles. You can define what's the scope of those pre-canned roles. You can associate or in fact influence your consumers to pick one of those roles that you have out of the box created. And thereby, regardless of whether it's tenant 1 or tenant 2, they pretty much are accessing your system to access the same set of APIs. However, when it comes to the actual data, how it gets accessed, how will tenant 1 and tenant 2 not have this or have undesired access of inter-tenant data access? How do you create data isolation, tenant isolation? I think Miranda touched on it briefly, but the reality is when it comes to data access, you've got to use the tenant information in the token that gets passed along all the way through to your backend so that your APIs are easily able to delineate which data stores is this particular request hitting. And by the way, it doesn't mean that just because you're in a pooled model, your data stores have to be pooled either, right? So again, you have a spectrum there. You can dedicate a data store or you can go row-level security. Invariably, the tenant context makes sense to be enforced by the backend API in terms of data access.
Thanks, Sri. Good answer. So we're quickly running out of time. One thing that I think Sri you wanted to share was, so today's show has all been about AWS native access control. But the next question is obviously, well, what are the alternatives if you want to use something else? And there are feature mapping. You've got wonderful partners like Launch Darkly and others. But Sri, there was a specific link you wanted to share too. Right.
Yes, and it is an absolute coincidence that the blog post came out, and this is something that as we were, let's first focus on solving similar challenge with AWS native options where the convenience is high, but at the same time we were open to the idea of, look, I mean, it's not always practical for customers to have made technology choices, and in most cases they have to just work with the technology choices that they've already made. So what could be some of the alternatives that exist? And Auth0 was something that has come up quite a bit amongst the conversations that we have with our customers on a regular basis. So there is a blog post that has come out where it talks about, in SaaS multi-tenant world, how would you go about securing your APIs, which is both authentication and authorization. And we talked about authorization today. It is a similar construct. And I'll map it back to this, but there was one of the questions around what if there are way too many APIs where the IAM constraints on the size of the policy and the number of policies that can be asserted to the roles will start to come up, and which means that we have to split against multiple instances of IAM or corresponding roles. It also helps in that particular regard. To be able to solve, again, I mean, we will be transparent upfront here, right? Every implementation will have its limits. If you really have to, if you're playing in an arena where you have literally hundreds of APIs, first of all, I would urge you to think about, are all these hundreds of APIs your backend for frontend? Because that is where we would want to authorize, like Miranda said. Second, if you say that, yes, I have very, very, great list of functionality that I provide. I'm a really great SaaS provider with various functionalities that can be used, and therefore, so consequently, I have hundreds of BFFs. You have to break away from a constrained model to perhaps a more, let's say, scalable model where you then have to define, like Miranda touched on it. I'll repeat it or reinforce that point, which is each API, or in this case, each BFF, has to be aware as to what it has to allow and what it doesn't have to allow. Which means instead of your API gateway becoming the enforcement point, you have distributed or decentralized the enforcement point at an each BFF level. So this is, I think, that previous question, I forgot the name of the person who asked that, which is what if you start to brush up against the constraints of policy characters and the number of policies on IAM, in which case it's worth sharing before we talk about Auth0 is OAuth 2.0 has a provision called scopes, which is a special claim specifically to have a space-separated list of strings, and each string represents a scope, which subsequently represents in your API implementation your API endpoint. So the way to come around the centralized enforcement and centralized definition and decision point is decentralize it, meaning that instead of your API gateway, each API has to be aware of what it must allow and must not allow, which means that when a user authenticates and successfully receives an access token with the scope information, it's the scope claim of the access token which says this particular user has access to these 100 APIs, right? That is more scalable if you are brushing up against the IAM constraints. But be aware that you are putting now the power and the responsibility of authorizing access in the hands of the developers, because each API has to look up the scope to allow or disallow. So now let's come to Auth0. The reason I said, touched on these things is Auth0, much like, user pools and cognitive identity pool, it's compliant with OpenID Connect and OAuth 2.0. In my understanding so far, again, this is quote unquote, think of it as my perception here, or my understanding, Auth0 does the scope part a little better than the native implementation that we have shown. So if you have to go to a model where you want to capture authorization detail or mappings within a token, that is the access token, Auth0 makes that provision and makes it one step more powerful if you want to go down that path. Now, the blog post talks about how Auth0 offers that multi-tenancy. And again, Auth0 is an AWS partner. And we would love for our customers to solve their problems using a swathe of technologies, and we love the fact that there is optionality that is available. What we are interested in as solution architects is to help you progress with a certain momentum to solving that problem. And in that vein, I think that blog post link, if we can paste it here. Do I paste it on the chat?
I put it in. It's already in the chat.
Perfect.
Lovely.
Yeah. So take a look. Again, that's a coincidence. It just came out on the day when we were doing this. But hopefully it makes sense. There's a lot of commentary here, but look, hit us up, reach out to us if you want to have a chat at a deeper level, especially if you're in the midst of action doing this at your workplace.
Lovely. Thank you, Sri. Thank you for joining us. Thank you, Miranda. This is our show for today. Wonderful engagement. Thank you for all the questions in the chat. And for anyone who's looking at this on YouTube as well, thanks for joining in. This is our second last show. The last show is in 2 weeks. That'll be it for the season, but we will absolutely be back in February next year. So tune in 2 weeks, and we'll see you then. Thank you very much, everyone.
Thank you.
Thank you.